Hello everyone, good morning. My name is M. Krishna Prasad and I am from mechanical background. Today we are going to discuss about a topic called plant simulation, or we call it as a concept of simulation. So, okay, so let's start with the topic. So what exactly a simulation is? What is a plant simulation? Where exactly it is using? All these topics we are going to cover in this discussion. Okay, so let's start with the basic. So for any production or for any mechanical industry, for anything, the basic thing is a production technology. So what is a production technology again? So what is a manufacturing technology, or what is a production technology? What is a manufacturing process? So all these will be depend on some concept. The concept is nothing but the definition. The definition of the manufacturing technology or a production technology is nothing but it is a process of conversion from raw material to end output. That is nothing but a manufacturing technology or a concept of production technology. Okay, so in this manufacturing, so we are going to convert our raw material into useful product, so which we desire to be. Let us take an example, like if I want to prepare this key. Okay, this is my output, I want to prepare this one. So I have some raw material with me, some ms or some ss. I have some raw material. Converting that raw material to useful product, so this key is give me between process nothing but a manufacturing process. Okay, well, coming to the main aspects, nothing. So what are the process which will going to take in an industry, or what are the main aspects in an industry? So if I want to run an industry, if I am having an industry, what are the things that are essential for industry to run? There are 6 factors will be there that need to be where, that need to be done, that need to be present in every industry to run on its own. So let's discuss about the aspects of the manufacturing. So first aspect of the manufacturing is nothing but raw material. Why the first aspect is raw material? Okay, without the raw material we can't do anything. So if I want to prepare a product, okay, then all I need is a raw material. Without the raw material I can't even produce anything. So I need a raw material. So this is the first aspect of the manufacturing technology is nothing but raw material. So what is the second aspect? The second aspect is nothing but a mission. So if I am having a raw material and I want to prepare some output, so how can I supposed to make that? With the help of some missions. Okay, with the help of missions only I need to do that. Again, missions may be separate types, will be there, like conventional missions will be there, some CNC missions will be there. That doesn't matter. Okay, we can do our process in a conventional, or we can do our required process in a CNC. Okay, that is the next step. So for industry, what is the second aspect, or the second one strategy? Second one, that is the last one, that is nothing but a mission. So what is the third one? Then we'll come to the third one. So third one is nothing but procedure. Okay, if at all I am having a raw material, I am having a mission, and I want to produce some output, then what is the thing I need? Definitely need, I need some procedure, set of operations to do that thing, then only we'll get the required outputs. That is nothing but a procedure. So without the procedure we can't do anything. Even if you are having a mission, if you are having some CNC missions or numerical control missions or conventional missions or some automated missions, all I need is a procedure, then only we'll convert that raw material into useful output. So that is the third main strategy. Okay, so what is the fourth one? Again, the fourth one is main one is time. Okay, so let us take an example. So if I'm having conventional mission and I am having a CNC mission, I want to produce a product. So and for I want to produce this one. Okay, I will produce this in the same conventional mission as well as in CNC mission, but the main thing is time. So how much time it is taking to work this output in a conventional mission, I will compare that with the operations in CNC mission. Definitely, if at all it will take 2 hours to produce this thing in a conventional mission, but at 20 minutes time it will take in CNC mission. Which one I need to pick? Definitely I will go for the CNC one. So the fourth main aspect is time. So if I want to produce 100 number of outputs or 1000 number of outputs, definitely I use a mission which will give more output, more productive output than a slower one. So I will definitely choose some CNC mission or fast operation missions. Whether, okay, let us take another example. Maybe this operation will be performed in a conventional CNC mission for 20 minutes, but the same operation will be performed in a normal conventional mission in 5 minutes. Then which I need to pick one? Which I need to pick? Definitely I'll go for the conventional. Why? Because the time taken for this processor is 5 minutes. Definitely I'll go for it. Even though the CNC is having automated programming everything, but still the time it is taking is 2 hours. So or 20 minutes. Why I choose that one? So I'll choose the less time. Why? Because it will definitely depend upon the productivity, final output. So I'll go for the less time taken. So this is a major aspect. Then after the time, so what is the another main aspect? That is nothing but a cost. Again, cost is the main factor. See, like I have given you example, this one is preparing, the time taken to produce this thing in a CNC machine is 20 minutes, and the time taken to produce this thing in a conventional machine is 2 hours, and the cost, that is that consumes in a conventional machine is nothing but let us take an example of 20 rupees. If at all I use to produce this operation or this output in a CNC machine, and that cost me 50 rupees per piece, again which it is supposed to pick? That should be depend upon the cost factor, and again that should be depend upon the number of product output. If at all my production is continuous output, continuous production is there, some batch production, mass production, then I'll prepare some calculation and put some analysis report, and finally I'll get a sheet from which mission I am getting the profit or getting less amount and get more output. That I need to discuss. Okay, let us discuss again. So what are the main aspects in an industry? First one is raw material, second one is mission, third one is processor, fourth one is time, fifth one is cost. And what is the another aspect? Human beings or workers. Without the human being, without the workers, missions won't run on its own. Even the industry is automated or robotized, but still workers need to be there. Workers need to perform. Workers here or workers nothing but engineers, supervisors, whatever it may be, human beings. They should be there in industry for giving the operations to the missions. If at all it is a robotized one, we need to give the program. The workers need to give the program to the robot. If at all it is an automated, then the workers need to check the automating missions, automatic sensors, every components of the automation continuously. Then only the machine runs on its own. If at all a problem rises in an automation or robot cannot do, they rectify their problems on its own. It definitely needs a human interface. It definitely needs some human interaction to solve that problem. So these are the 6 main aspects in an industry. Okay. So now we have discussed like what is the manufacturing concepts and what is the industrial strategies, what are the main strategies, what are the main aspects of industry. Now I'll come into the process. If at all I want to prepare an object, okay, in a plant. So how actually the product will starts? Okay, this is nothing but a product life cycle management. Okay, so I will call it as a product life cycle management. Why? Because if in an industry I want to prepare a product, I want to prepare a product, okay, that product was initially started with an idea, okay, idea or thoughts. So first one is an idea, assumption. Okay, first I have an assumption to prepare that object. Okay, I have my assumptions. Next, what is the main thing again? So I need to have a design first one. Okay, I need to have a design, proper design. See, I want to prepare this pen. Okay, first all I need is a design. Without the design I can't even explain it to the engineers, or I will go directly to the worker who is operating CNC machine. I want to say him that I want to prepare a pen with having this much of diameter. Okay, it won't be possible. They need definitely a drawing to get a precise output, to get a desired output which we have assumed. Okay, so for that thing definitely we need a design. Okay, again for design we will have a design software. In design software we will design the product and we will prepare that product. Okay, and we have completely manufactured this product. We have completely designed this product in a design software. Once my design is ready, then what is the next thing? Definitely I'll directly go for manufacturing. Somewhere it is okay, but if it is a steel body or if it is a plastic body, what will be happen if I directly go for manufacturing? See, I will design it and I will consider this design and I will drafting it, and I will prepare some data sheets and I will drafting sheets, designing sheets, and I will give it to some CNC, some worker which is working on a CNC or conventional machine, and he will directly prepare it. And what will be happened here? So the time taking for this procedure, if at all I choose the CNC machine, what will be happen? He need to check how much diameter is, how much taper is there, and he need to go for so many trials to get this desired output initially. Why? Because without any programming. So he need to run on its own. Okay, once everything goes well, still it needs lot of time, maybe 2 hours or 3 hours to prepare this pen. Why? Because it is not there is no any program to prepare directly this pen. Why? Because it is having so many grooves will be there, so many cuts will be there, and tapers will be there, angles will be there, grooves will be there. That is difficult to perform manually. Okay, so what is the next step here? So first one is a assumption, second one is a design, third one is I will say it as a computer aided manufacturing. I will convert that computer aided design into computer aided manufacturing. So what will be happening in a computer aided manufacturing? So automatically this pen will be manufactured in a virtual software. So with the virtual software, what will be happening? The same thing which will be happening in a outside or a original raw machine, CNC machine, that will be happening with the help of virtual manufacturing software. That is called a computer aided software. In the computer aided software, we are going to design this complete pen again. So what will be happening here? Then I will give some operations to remove the material, complete material, and I will prepare a final output like this. And what will be happen? So after preparing all the programs, after all the operations, then there is a command called in CAM called post process. Once I will click the post process with the basic mission. So if I am having some 3-axis mission or a 2-axis lathe mission or some mission, okay, based upon the mission, I will click that mission in the post process. So according to that mission, the program will be generated. see, let us take an example. This can be operated in a lathe machine, CNC lathe, okay, and I'm having 5-axis machine also. I can directly put a program in a post process like CNC 2-axis. So the program will be created according to the CNC 2-axis. If at all I click CNC 5-axis and click this one to program it, what will be happen? The program will be prepared according to the 5-axis machine, according to the convenience of this 5-axis machine. Then what is the difference between this 2-axis and 5-axis? So this in 2-axis program, what will be happen? The complete operation will be performed according to that 2-axis only. This one will be holding and the tool will going to cut the every operation. Whereas in 5-axis, what will be happen? Same thing will be happen, but for a smooth operation, automatically the tool will tilt and the workpiece will be tilted and the voice will be tilted for convenience. Okay, that is the main difference. Nothing difference will be there. So once we are ready with the design, then what will be next thing? So the next thing is nothing but a manufacturing. Once the manufacturing is ready, programming is ready, then what I supposed to do? I will directly go for the manufacturing. Why? Because I already created a virtual design. It is running perfectly. Then I will go for the design, and what will be happen over there? So I will give that program to the CNC machine and I will operate it, and I will get a desired output. Well, there will be no errors in a virtual to realistic. Why? Because everything will be same. The aspects of all the parameters which are there in the CNC machine will give that parameters to the virtual one. So there will be no any difference will be there. Once my output is ready, then I will forward it to the digital marketing team, and they will exhibit it. Once it is exhibit ready, then what will be happen? Again, it will go into the market and it will donated. It will be marketed to all the candidates. It will go into all the persons, okay, all the people outside the market, and it will enter into the market. So once the product enter into the market, what will be happen? Again, the salesperson will come and collect the feedback after few days. Once the salespersons will collect the feedback, again they will forward it to the industrial persons. Once the industrial person receives the feedback, again what will be they do? So they will refer all the feedbacks and they will try to convert all the negative feedbacks, all the drawbacks, and they will convert it to the positive ones, and they will try to improvise the design, and that design is nothing but a improvisation or next model of this pen. So initially I have designed this pen, so let us call it Cello 1. Okay, after few months collecting all the feedbacks from the people, okay, by the outside people, then what will be happen? The engineers will do all the rework, converting all the drawbacks into the positive ones, all the defects into the positive ones, and they will try to change the design and try to change the aspects of this pen which will draw back in this pen. Once everything is ready, again I will release it as a Cello 2.0 or 1.0 with a new version, like that. So this process is nothing but a product life cycle management. Okay, it all starts with a assumption. Next one is a design. Third one is a aided manufacturing or a virtual manufacturing. Fourth one is a original manufacturing. Fifth one is inspection, and sixth one digital marketing and advertising, promoting. Next one is forwarding it to all the people, and sixth one is collecting feedback and giving the feedback to the engineers or whatever it may be, and next one is collecting the feedback and reviewing the feedbacks, and sixth one is implementing the feedbacks, converting the defects into the positive advantages or reviews, and finally again new product will be designed by considering all these defects. So this is what the product life cycle management. Okay, so this is nothing but, and in this process we are what are the process we are doing virtually here. So from the design to manufacturing, we are doing all the process. This process is nothing but a simulation. Okay, the concept of doing this procedure, from designing to virtual manufacturing is nothing but simulation. Okay, this is called as a manufacturing simulation. If at all I want to convert this manufacturing simulation into plant simulation, so what exactly the plant simulation is? So what is a plant or what is an industry? Industry is nothing but the process from raw material to end product. The in-between process is nothing but an industry. Okay, from the raw materials coming into the gate, and they enter into trucks, and they're traveling into some conveyors, and the material is traveling from conveyors to the machines, and machines will work by the help of workers, and once the output is ready, and it will travel to the by AGVs to the inspection counter, and when inspections are ready, then what will happen? It will be dispatched to the dispenser, to the packing center. Again, packing will, what will it do? They will pack the objects, and once the packing will be ready, they will load it into the trucks. So this all complete procedure, if at all this process is completely put it in a virtual manner. So what is again virtual? Virtual is nothing but a computer one. So if at all I am doing this process in a computer, then this is called as a simulation concept. I will call it as a plant simulation. If at all I am doing this simulation for robotics, which means there is a robot is there. I want to prepare that robot. I want to give the robot a program. So to pick an object and place it somewhere. and I want to do that operation in a virtual manner in a computer. That is nothing but a robotic simulation. If I want to prepare a process, like if I am having an assembly line is there or a production line is there with having 4 machines and some conveyors will be there, and I want to design that process completely from the input entering into the first machine to the output exiting from the last machine. In between process, this is called as a process. If I want to do that process virtually, that is called as a process simulation. Again, if a human is working on a mission, he is picking some part and placing somewhere, and if he is operating the mission, and if he is traveling to some other mission and doing the same work, and after completing the work, again he is coming here and he is loading the mission, and he is removing the output. So this concept, if at all I want to do all the human interface thing in any mission with what he is doing in everything, this is called as a human simulation. Okay, now I think you all are know what exactly a simulation is. Simulation is nothing but it is a software, virtual software, which can be performed, okay, which can be performed virtually. Simply, that is one. So the process which you are doing realistically in an industry, doing that process in a virtual platform is nothing but a simulation. Okay, so now we have talked about that what is exactly the simulation is. Now can anyone tell me what exactly the simulation will do? So why exactly we are using simulation? What are the advantages of simulation? I will say that also. Okay, by the help of simulation, what will be done? Okay, so in the previous example, we have manufactured our product in a mission, okay, virtual mission. Why? Because to minimize the time. First thing, why? Because if at all I want to prepare this pen directly in a CNC mission, it will take time. Why? Because it is having so much complex of shape, and I want to prepare it in directly CNC mission. Again, it will consume me a lot of time. Let us take an example. If at all I want to do this in virtually, so what will be happen? Directly I will give the programs. So I want to do what are the operations I do. So I will give the operations to remove the material. So the machines will automatically remove this part, and they will prepare completely. Even it is having a complex shape like this, even after their grooves. So if at all I want to prepare this, there is a programs. Directly I will give the programs. So automatically the material will be removed, and it will directly convert into the raw codes, coding manner, G codes or M codes by the help of some post processor. So complete this process it will take some for 2 hours or 3 hours, maybe 4 hours. But once the program is ready, and it will take only few minutes to upload that program into CNC machine. So what CNC machine will do? CNC machine automatically run this operation continuously without need of any human interaction or human interface intervention. Okay, this is what the advantage of virtual softwares or simulation softwares. So in simulation software also, if at all I want to prepare a plant simulation, which means I'm having a plant with some 20 number of machines, with some 20 number of conveyors and 3 robots and some gantries, input is there, output is there, everything, it is continuously running 24/7. So if at all I want to do the plant simulation, so what it is supposed to expect? If at all I'm a person who is having an industry and I want to buy a simulation software, okay, so what is the first thing I will supposed to think before buying or before using some simulation software? Okay, simulation software basically used to increase the productivity, okay, to know the where exactly the process is lagging, where exactly the time is consuming, where exactly the analysis will be there, bottleneck analysis will be there, where exactly the material handling is not exactly moving perfectly, where exactly the process is lagging, where exactly the process is delaying, okay, why exactly we are not getting the desired output which we already designed for in a theoretical way. So all these concepts, all these aspects will come into my thought, come into mind while buying or while using this software. So this is why I will definitely use this plant simulation software or what are the simulation software. Okay, so this is what the simulation. In clear words, I'll tell you. So what exactly a simulation is? Simulation is nothing but removing the barriers from virtual to physical or realistic one. Okay, so let us take an example. In virtually, I am preparing, I am doing some operation from mission 1 to mission 2 in 3 minutes. So mission 1 input is coming to the mission 1 and mission 1 is completely doing all the operations, and worker is picking that part and is placing it in the mission 2. This all complete process will take some 2 to 3 minutes virtually, but in realistic, so it is consuming me 6 minutes. Why? I will analyze that part. I will directly go over there and check what will be happen. The worker will consuming time. They will is removing the material and even try to clean all the mission, and in trying to remove the chips which is inscribed in this mission, and he is removing that part and he is placing somewhere, and again he is putting the part in. Once after putting the input ready, then only he is carrying that part to the next station and he is putting over there. In the meanwhile, if he is having any work, any emergency work, he will put that mission on hold. Like these are the many stand-up problems will be there. That problems can be rectified by the help of simulation. So again, what will be happening to the simulation? So if at all I'm having simulation, so I will directly have a time, precise time for the procedure. So for first operation to first mission to second mission, for doing operation and transfer that output to the next mission input. So it will take 3 minutes. So definitely I'll go to the worker and directly ask for what is exactly it is happening over there. Why exactly the time is taking 3 minutes to 6 minutes? Can you please explain it? So this is why. So we are having a virtual everything in a realistic manner, everything in a analysis manner, reported manner. So we can directly increase our productivity. Or if a process lagging, if the worker is difficult to hold that part and is traveling all the way to the mission to and is putting over there, and this process is taking some 5 to 6 minutes, then what are supposed to? I'll put a conveyor on that. First I will try that in a virtual way. So directly what will be happen? And one more thing. So what will be happen if I put directly conveyor over there? Whether it is advantage or disadvantage, that I don't know. So if at all I invested some money and put the conveyor over there, and the conveyor is lagging time again, so it needs some maintenance, and again it is lagging so much of time, then what is the need of putting conveyor over there? Sorry. Then this process can be first checked by the simulation software. This is the help of simulation software. Simulation software is nothing but creating our own process, creating our complete industry virtually. If at all, like I already told, if at all I am having 20 missions and 3 robots and some AGVs will be there, conveyors will be there, and everything is there. First, what I need to do? I need to prepare a layout of the plant, and I'll import all the missions and I'll put all the process which is happening in the industry in virtually. Once my plant is ready with the virtually, then I'll assign AGVs, I'll assign robots, and I'll assign humans and everything in the plant. Then I'll run the simulation. Simulation is nothing but doing the process what is happening in the industry exactly virtually. So if at all I'm doing the complete process virtually, so I will get some X number of output by the end of the day, which is somewhat more than the realistic output. Why? Because in realistic there will be lot of errors will be there. Why? Because it is not having any simulation concepts written over there. So directly what will be there will be so much drawbacks will be there. Humans are directly involved in over there, and automated some breakdowns will be there. Everything was there. So if at all I'll compare the result realistic one with the virtual one. Virtual one is always greater. Why? Because virtual is one which is producing continuously without any drawbacks, without any errors, without any breakdowns. So in realistic there will be a lot of conditions we need to consider. Now I'll tell you again. So what exactly a simulation is now? Can anyone please? I think you are understand with the concept of simulation. Again I will tell you what exactly simulation is. Simulation is nothing but it's a virtual software that is performing the complete plant process. Okay, so this is what exactly it is happening, or simply performing a task without any physical means. See, if at all I want to improvise my industry, I'm having 20 missions, or like I already said, I want to increase some other 10 more missions, and I want to create some production line, okay, with some involvement of some 10 missions and 3 robots, some conveyors and everything. So what is the procedure? So can I directly go to the industry, or can I go to directly some shop and buy some CNC machines and everything, the equipment, and directly place it in the industry? Is it the correct way? No, it is not the correct way. So in industry, any industry, if you want to buy a mission or a process or a layout, if you want to involve a new mission, involve a new equipment or a new process, then it should be done virtually first. Why? Because we need to check whether we'll get the desired production or not. So if at all I want to produce some 10,000 outputs again with that assembly line, first I need to check whether all the missions, I need to design that product in a virtual platform, simulation platform. I need to assemble all the missions in a way, in a line, so that no any delay will be there. Again I use some conveyors, again use some AGVs, and again I use some involvement of human and everything. And once I will prepare the layout of the complete line, then I will start running the tests. So by entering the material, by exiting the material, I am giving the time taking for the procedure, I am taking everything, and I will calculate the output. So how much output I am getting. If at all I install this complete assembly line or complete production line, so how much production I am getting after installing this one. So first we need to generate all the reports, and after getting all the reports, then only I will get an approval from the higher department or a higher one. If at all I am the in charge of the plant, then only I will give approval for purchasing the mission. Otherwise, without any data, complete analysis of the data, it is impossible to go in directly improvise a plant or increase your plant, anything. So this is the first step. So for getting all those things done, so we need definitely a software. That software is nothing but a simulation software. By using the simulation software, again what will be happen? So I'll create the complete process virtually. Once I am satisfied with the results, then I'll start buying or I'll start importing that missions according to my virtual design simulation concept. So once my concept is ready, again what will do? I will give all the inputs to the machines or the workers, so that this is what going to happen. This is what you need to do. I'll give directly the task to the workers. So by the end of the day, you need to produce this much of time. If at all anything there, you need to update it. Like I need to give the comments directly over there. So this is what the concept of simulation. So with this, I think you all know about the concept of simulation. It is easy to understand. Simulation is nothing but it's a virtual software that can be performed to operate a plant, to operate a machine, to operate a robot, to operate a human being. Everything can be simulated virtually. Okay. So this is what the concept of simulation. Again, plant simulation can be done for continuous. If at all my industry is a continuous production industry, then that can be done easily. Discrete or continuous events can be there in an industry, that can be done in a simulation. Why? Because continuous production will be there, continuously automation is there, continuously the industry is running. At that type of industry, if at all I want to remove one mission, if at all a breakdown is there, if I want to improve some mission, a conventional mission to CNC mission, then what will be happen? So first I need to check whether it in a virtually, if at all I place a CNC mission over there, how much time it is taking, what is the process that need to be done for a CNC mission to set up, how much time it is consuming, how much time it is involved to get the output, how much output I am getting, what is the output factor that is increasing, what is the production rate. So whether it is increasing or decreasing, that can be done by the help of simulation software. Okay. With this I am concluding with the topic like simulation. So now I am telling you again, so why exactly we are using simulation here? Simulation is nothing but it is a software that can help any person, any industry to improvise their production, to increase their production rate. Okay, so to utilize their resources continuously, or to continuously monitor their logistics material handling systems, everything, or they get the brief analysis of the reports, or some analysis of the material flow, resource utilization, everything. These are all called as the advantage of plant or simulation software. There are vast number of things that can be that we will getting by the help of simulation software. Okay. Again, this simulation software, we are completely preparing this plant in a 3D environment, not a 2D one, or not like a basic one. So the platform, the simulation software is nothing but it's like a completely virtual one, like a visualization one. So we can prepare everything, the mission, some man, workers, everything, realistic one, 3D models. Okay. This is why the simulation software is nothing but a 5D concept. So again, 5D, what exactly the 5D concept is? I'll tell you that 5D concept is nothing but it's the involvement of 3D plus time plus cost. What exactly 3D? 3D means three-dimensional one. Three-dimensional one is nothing but the objects which you are creating, whether it may be CNC mission, whether it may be mission, whether it may be a robot, whether it may be a human being. These are all called 3D models. Plus, what is the again plus 2Ds? One is a 4D and 5D. 3Ds are nothing but three-dimensional one, and the fourth dimension nothing but time, and the fifth dimension nothing but cost. With the help of this 5D, the simulation software comes into place. These are the 5 things which will be done in a virtually. So we are creating an object in a 3D. Okay, once my object is ready, then I am giving some time to and performing operation, and finally I am getting the cost also. So how much cost I am efforting in this, how much time it is taking to complete the process. There is an option called, if at all this cycle time is there, this much of cycle time, I need some 10 rupees of cost. So for the sake of preparation, some 10,000 items, how much time it is, how much cost is it is expecting, that every data sheet can be done by this help of simulation software. Okay. So with this thing, I'm concluding that simulation software is essential for all the industries. Why? Because in the present situation, everything is automated and robotized. Even the automation robotics can be done by the help of simulation software. So with the help of simulation software, we can directly, if the plant is running with the help of some X output, some production rate of X, then if we use simulation softwares in the industries, you will definitely get your production increased by X to Y or Z, some other concept, or X1 or X2. Definitely if you use the software, then what will be happen? The production rate will be definitely increased. So this is what I'm trying to say by the help of simulation software. Okay. Thank you.